LeetCode problem number 778, swim in rising water. So this problem gives us a n times n integer matrix called grid, where each value represents the elevation at that point, ij. So here it says, when the rain starts to fall, blah 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 blah. Okay, so to summarize everything, basically from the top left corner of the grid to the bottom left corner of the grid, we have to find the path that has the minimal elevation, right? So you can see all these values here, they are cost to basically reach their cost to stay on this box basically, right? And we have to find the path that would minimize the entire journey, right? So for this instance, we cannot cross on 17 here or above 17 at all. So we want to minimize it so that the maximum number is minimized. Yeah, that's a better word for it, right? The maximum number is minimized. So in this case, 16 is the maximum number. We have to return the, so here we have to tell it the least time you will need to reach the bottom of the square, which means that we have to return the maximum number in the path we have, right? Because in the questions, it also says that we can swim infinite distance in 0 time, right? So this means that from the top left corner of the grid, we can swim to the bottom right corner of the grid in an instant. But we need to know the, we still need to know the maximum time, which is 16. Okay, so my approach to this problem is to use the Dijkstra's pathfinding. So the Dijkstra's algorithm is a breadth search algorithm. So it will require us to use a priority queue that is sorted in ascending order, right? So here, at first I have the size. So this size would basically tell us the size of the grid in terms of the row, because I'm pretty sure the grid says, yeah, n times n, right? So it's confirmed to be a square grid. So let's say my grid is like so. I'll use a small one, so there wouldn't be too much calculation going because Dijkstra's algorithm is takes a while to run through. So here I have the distance. So this distance will basically keep track of all the distance from the of the grid, right? So at first I'll keep everything at in max, and later on we will be updating this to the smaller distances, right? So here you can see I immediately turn the top right corner into the distance of 0. Be sure, yeah. Okay, so this is 0. Here I have a priority queue. So this priority queue looks a bit scary, but all it does is it stores 2 pairs, right? So it looks something like this. Pair 1, and then A, B, and C, right? So this A here, what you store is the distance, or this distance of the current grid, right? And the value, in this case, you can treat it as a map as well, but we have to use a priority queue, right? So the A here, in this case, it's storing the distance, and the B would store the x and y coordinate. Oh no, yeah, the B will store the x and y coordinate, right? So row, column, right, or x and y. So the first thing I do is I push. Okay, I'll leave that there so you can reference it later on. I actually call this cost. So I will push the first square. So right now it looks something like this. Okay, I'll do it like this so it's easier to see. Let me change. So these two int arrays, they are basically just helper variables to basically iterate through where I need to go next in the Dijkstra algorithm. Right. So here we have -1, 0 means it's going up. Right. This means going down. This means going left. This means going right. Something like that. I think this is going left. This is going right. Either way, just a helper variable. So while my priority queue is not empty, so in this case I do have something in it, which is the initial value we have. So here I jot down the cost of it. So the cost currently is 0, and so is the row 0, column is 0. Okay, I'll do it like this because we might need the space. Cost 0, row 0, column 0. Okay, after that I pop it. Now we begin the Dijkstra's algorithm, so we have to figure out where can we go. So obviously we can't go up, right? Or we can't go left as well. So the only way we can go is right and down. So with that in mind, I will just focus on the right and left, right? Okay. So let's say we reach the first one, which in this case, next row would be 1. Next column, actually row will be 0. Column will be 1, right? So we are at 2 right now. So here I check, okay, so this is the if statement that checks whether or not I'm going out of bounds. Right? So if next row is more than size, or if next column is more than size, or if they are less than 0, then I just continue because we don't want it to crash because we are going out of bounds. Afterwards, we get the maximum values between the two. So we see whether or not the current cost, which is 0, we see whether or not the current cost is more than the cost of going into that path, right? The current cost registered in our distance, sorry, not in the cost. So maxi or max integer would equals to, let me name it better. So max cost would equals to the maximum of cost, which is 0, and the grid, which is 2. So obviously max cost is going to be 2, and 2 is not more than, or more like the distance registered in the distance vector is more than the max cost, right? Because I registered it as in max. So what we do is we update it to the actual max cost of from this path going to that path, which in this case will cost us 2. If you were to choose this circle, if you were to choose this path, it will cost us 2. So here we put it as 2, and we push into our priority queue because we would have to, from 2, breadth search again. Priority queue, we are pushing the max cost, which is 2, and the row and column. In this case would be 0 and 1. So let's move on. Now we are at, now instead of 2, we are now going to 1. So for 1, it will be row 1, column 0. The max cost in this case is 1, right? That's what was written here. So if we do the maximum of the current cost with the max cost, with the grid's cost, which is 1, you can see 1 is bigger than 0, so we put 1 here, which is 1, right? So since the distance registered is in max is bigger than 1, we have to update it and push into the priority queue. And here, because this priority queue is sorted in ascending order, so the smaller the cost, the higher in the queue it will be. In this case, the 1 will be pushed up, right? So we're going to ignore the higher cost first and focus on the lower cost first, right? Okay, once that is done, this for loop will end, and we go to another iteration of the while loop. So currently, the top of our queue is 1, right? And the cost of us coming to this path is 1, right? So the cost have to update to 1, and we are currently in 1, 0, right? Which is the position of 1. We pop this, and we run through the for loop again, running the breadth search. So we see, we can go back up, left, right, or bottom. So in this case, let me erase everything first. So in this case, we know we can only go up or right. So in this case, let's try if we were to use the next row. So next row would be back to 0. Right, next row will be 0, because 0 plus -1 will be 0. So we're going back up. This if statement does not trigger. And we check our max cost. So max cost would be the cost of the current cost, which is 1, and the cost of us going to, which in this case will be 0. So obviously the max cost will remain 1, which is the current cost of what it took us to come here. And we check, is the distance of where we're at, which is 0, is it more, this 0, is it more than our max cost? Since it's not more than that, means that we can just ignore updating it and move on, right? Again, is the cost registered in our distance, which in this case, if you look here, it's 0, right? Is not more than the max cost. Max cost is higher than 0, right? So in a way, this also tells us that we can't go, or more like we have already visited this particular box, because from this column from 0 to 1, it took us one step already. It took us one cost, right? So again, we ignore 0 because we have done that already. And now we go to 3, right? That's the next one we can go to. So for 3, row will be 1, next column will be 1. The max cost in this case would be 3, and the current cost 1. So 1 and 3. So the maximum will be 3. Okay, if you look here, the distance registered for this particular square is in max. In max is more than cost. It's more than the max cost we have so far. So we have to update it. This will become 3. And the priority queue will push cost of 3 with the coordinate 1, 1. Okay, once that is done, we are not done yet, even though we have registered all of the basically we have reached the path, we have reached the angle yet, but we still need to try at least from this box, right, to double confirm the answer. Just because we reach the goal doesn't mean that that was the most optimal path we took. Either way, we now run through another while loop. Now we're back at here, this 2. So the cost of it would be 2, the row is 0, column is 1, and we pop this, right? And we run through another for loop again. So for this time, we can't go right, we can't go up, we can only go left and down. But we know what happens when we go left, right? Is that the max cost, this doesn't trigger, and we don't get any new, we don't have to push into our priority queue, right? So basically going left does not really mean anything. So let's try going to the right side. So by going to the right side, next row is still 1, 1. Actually, just to be fair, we will try going to the left again. Right, we'll try going to the left and see what happens, just to be fair. So next row, next call are both zeros. It does not violate, we are not out of bounds, so we calculate the max cost. So max cost will be the max of 2 with the current grid we're on, which is 0. So we see 2 is bigger than 0. Since the distance registered is 0, it is not more than the max cost, right? 0 is smaller than 2, so we don't have to update this. Okay. Once we have visited the left side, we can now go to the downside. Downside, next row is 1, next column is 1. The max cost in this case would be the maximum of the current cost, 2, with the grid of where we came from. Right, this is 3. So when that is done, we check the distance. So the distance registered 3. Is 3 bigger than max cost? Right? No, they are the same. Right? They're not bigger. So this if statement will not run. After that, this for loop will end, and then we run through the while loop again, starting with 3. Right? With 3 as where we are starting our breadth search. And from 3, we can only go up or left. But since the costs registered inside of the distance is practically not going to be more than the max cost of reaching here, right? 2 and 1 are not more than 3. So this for loop will run just to check for that. Nothing will change. This will be popped. Our priority queue is empty. And then we return. What do we return? We return the distance it took us to reach this bottom right of the path. Okay, so this example is a bit it may look like a bit biased because the highest number is coincidentally at the bottom right corner, right? So let's try another example instead, right? So let's say this were to be 3, and this were to be I don't know, 2, right? So let's try for that. So this will be 0, 3, 1, 2. The distance, they're all in max. So again, we start from here. So we push the grid, cost of grid, which is 0, and this would be the position we're at. So while the priority queue is not empty, I'll try to speed through this because I've already explained it once. So first row column are all zeros. We pop this, run the for loop. We can only go to the right side and the left side. So for the let's look at going at the right side first. Next row is still 0. Next row is 0. Next column is 1. Right, the max cost is the max of 0 and where we're at, which is 3. So max cost will be 3. Since the distance registered is in max is bigger than 3, so we update it to 3. Right. Afterwards, push with the coordinate 0, 1. Okay, next we try 3. Next go to 1 now. So 1, it will be 1 and 0. Max cost will be the max of 1 with the cost of us coming here, which is 0. So max cost is 1. In max is more than max cost. So here we put 0. This is going to be 0. This is 1. This is 0 because over here we registered it as 0. Okay. Then we push 1 with 1, 0. So this will move up because this priority queue is sorted in ascending order. We run through the while loop again, starting from here. Cost of us coming here is 1. The current row is let me make some slight adjustment. Let's make this 0 so we can better visualize what the priority queue is actually doing. Okay, so max cost from 1, 0, which is here at position 1. So we know what happens when we go up, so let's try going to the right side instead. So right side will be 1, 1. Max cost will be the cost of us coming here plus the cost of going there, which is 0, right? Over here, 0. The cost of going to the right is 0. So the max will be 1. Hence 1 is lesser than in max, so we update it to 1. Push again the max cost to 1 and 1, 1. Okay, so from here, since we're done with the distance vector, I will not touch the algorithm again because we all know what's going to happen. They're all not going to be more than that. So if you see here, this 0 has been turned into 1, right? So practically speaking, this distance is keeping track of the cost coming to this particular position, right? The cost coming particular to this position. So if I erase everything, and if you see here, the cost coming to this position, so this originally was 0, right? The cost coming to here was 1, which came from here. And this one was brought because of the value we put into the priority queue. Okay, and once we're done, we just returned the cost coming to the last box, which in this case would be carried, which in this case the previous cost will be carried forward into the end goal. Alright, that's pretty much it. That's all I have to show. Thanks.